Remember, we were looking at solving a system of equations, basically finding out where two lines cross, if they did cross, and that would be the solution. If the two lines were different, wasn't there one solution? It would be where my finger is pointing. If the two lines were parallel, there was no solution. And if you ended up the same, there would be an infinite number of solutions. And there was a number of different names attached to these. I'm just giving you one of them. This is, for instance, equivalent or dependent. This is inconsistent. This is consistent, independent. This is inconsistent. So there was a number of different names for these types of situations. But if two lines crossed, there was one solution. If they were parallel, there were no solutions. And if it ended up that you ended up with the same line twice, there was an infinite number of solutions. And we spent a fair amount of time just getting used to drawing two lines. Sounds familiar? That's kind of what we did. And so what I'm going to show you, I just had somebody come in late. What I'm going to show you is there's a nice piece of software that is going to do that same job for us. So what this is going to allow us to do is that we don't need to do them by hand if we don't want to. Now, you might like the piece of software, in which case you'll use it. And if you don't like it, you'll do it by hand, right? Finding some points, joining them up and doing that. And I'm now going to hopefully, I have to close some windows. Well, I have to close lots of windows. And I'll show you. It's called Desmos. Darn it in space. Okay. Right. Almost ready. Okay, looks like I'm ready now. So in Canvas, in the usual place where all my good stuff is kept, you will find a link that looks something like this. You see it there? It's a program called Desmos. Now, I'm going to click on it, and with a bit of luck, it will just appear. Right, can you see the program Desmos now? Now, I'm just going to randomly pick some equations, and then we'll do real ones that would be more realistic. You could get an equation written as y equals 2x plus 1. Now, all I did there was type y equals 2x plus 1 in my keyboard. And hey, it's drawn. Wasn't that cool? Now I'm going to hit enter. And that's called the slope-intercept form. Remember the name when the equation of a line is looking like this. And the other line is going to be 2x plus 3y equals 6, because I want it to be. Right? And do you see the second line is also drawn? And the first line is red, and you can tell the first one is red because that little red thing. And you can tell the second one is blue. And I don't know how big your screens are, so maybe if I enlarge it a little bit, does that help any? Can you see now that you've got a very smooth, quick way of drawing the two lines? In this case, would you agree that it's got one solution and it's where I'm trying to point? Now, if I click on that point, do you see that you can actually get the X and Y coordinate of it? So you don't even need to guesstimate it. You just click on the dot where the two lines cross. Now, come on, is that not cool? Hey, is that not going to make that section a lot easier for those who are wanting to use it? You don't need to use this piece of software. Have I got a feeling that there's a good chance you probably will now that you've seen it? And that's okay. Now, have you noticed in WebAssign, typically all WebAssign does is say, tell me the solution or something along those lines. So this works perfectly for that, wouldn't you? You just have to type in that decimal comma this one. Right, so I'm going to put that guy, well, I'm going to leave that for a second, and I'm going to find a question. Okay, the correct answer is 4, -1, because I've still got the solutions up. but it's, I'll write this guy down so I can remember it. So it's going to be x take away y equals 5. That's the first line. And 2x plus y equals 7 is the second line. And the solution is x is 4 and y is -1. So let's see if that's actually correct. Okay, are you still looking at Desmos now, or things went blank? Oh, are we good? We're still looking at the graph? Great. Okay, so I'm going to make that one go away and that one go away. And I'm typing in x take away y equals 5, which was the first line. There you go. And 2x plus y equals 7. There's the second one. And guess what? 4, -1, just like it said in the WebAssign. Can you imagine how quick your homework's going to be for that section? All right. So we are good, I think. Is there anything about that you feel uncomfortable about, or you think it's pretty intuitive? You just type it in the way you see it and hit enter, right? If it's 4x plus 5y, you hit enter. I just thought of some possibilities here. It could be 1/2 x. And you may think, oh, how did he make that 1/2 appear? It's 1, the division symbol, right, the stroke symbol, 2, and it automatically makes a half. Let's suppose it was -3/4. So -3. The slash symbol is the one that's right in the bottom right-hand corner that's got the question mark on it. So if you're trying to find a key, it's in the bottom right-hand corner of your keyboard, and it's got a question mark on it as well. So there's 3, can't remember what I was going to say, 3/4. Let's change this guy to 2. And here's one of the cool things you can do about it. If you've got a mouse with the little wheel in the front, if you turn the wheel, it kind of goes backwards. And if you do that, it goes forward. If you keep your finger on the left mouse button, you can drag things around. So sometimes, you know, you can't kind of see it because it went off screen. Can't you shrink it down or slide it along? In this question here, would you agree that that is the solution, 7,2? I think I should do a parallel one, and just to see what it looks like, right? And equivalent one just to see what it looks like. So I'm going to keep that one, and I'll find something that's parallel to it. Parallel to it could be 3x take away 3y equals 6. There we go. Can you see those two are parallel? No solution. Right. You want one that's equal to it. How about that? Did you see the black one jumped on top of the green one? So there's actually only one graph now. So this piece of software, Desmos, is our friend. It's going to make solving systems of equations a lot quicker than doing them by hand. Any questions, or can we move on? You feel good about that? Right, you can have fun playing about with it in your own time. I'm going to move this guy over here. I'm going to stop sharing. Then I'm going to go back in and share it again. Okay. So on a scroll, essentially I'm scrolling through. I don't like these answers. It always does that now, and if I get to take it off. Right. Give it a second to update. Update. Take one off. Update. Take one off, and then third and final time, update and take one off. So can you see that what we've got here is basically just Sorry. Do we have a question? I'm not sure. Do we have a question? Okay. Can you see that you just get two sets of equations? And I don't know what the answer is, but can we pretend it's 4, 1? That's all you do, 4, 1, right? Suppose the answer was 4, half. Do you notice that when you click 4, there's a little thing over here that appears called MathPad? Can you see that? Right, so that's very helpful if the answer is like 3/4 and 5/4, right? Now, if you want 3/4, you hit that button, and then you can go 3/4. Then you can do comma, and let's suppose it's -1/2. Yeah, do you see how you type in fractions then? That's how WebAssign allows you to do fractions. I think Desmos is much nicer. Don't you just do 1/2 and it makes it a fraction? You don't need to worry about it. But in Desmos, you have to physically kind of tell it it's going to be a fraction before you even go near it. I think we are finished. How to solve equations graphically. Has anybody came across any problems in the first 3 homeworks? Because if you have a problem, I guarantee you're not the only one. That maybe I could fix right now and save you a whole load of stress later.
I have 2.
Perfect. Okay, Jamila, give me your first one.
Let's see. Hold on. Well, I know the first one. I sent you an email about it, like homework 1, where I'm stuck on the problem 15, because they won't allow me to change the answer or like click on the response.
Right. I'm not sure. Nobody else has gave me that, so I'm not sure what kind of happened there. So let's just go in and pretend I'm doing that question, right? And see if you were doing the same thing, because you might say, "Oh, okay, I didn't do that," and so that won't take me. Hopefully, that won't take me too long. Take me a few seconds to get the right window open. Of course, here we go. Math 99. What one was it again? What homework? 1 or 2?
It's 1, which is, of course, it's the intro one.
Okay.
But
and it's question number.
I think 14. No, not 14. 15.
15. Okay. So yeah. I'm just opening up student view, so I get to see what you did, and we'll show everybody else it. You know, if you haven't done this question, it'll be helpful. At least you'll know what you should do. Okay, so if I click on that, it's a quick way to get into the question. So it's this one here.
Yeah.
Okay, so we're going to. It's really getting you used to how to put answers in. So it's click here to begin. Okay. To find the sum of 2 add 3, you go 2 add 3 plus 4. You go in there and you hit 5.
See that I didn't put 5 because I thought it wanted us to skip the button, because it says if you don't know the answer, just skip it. So I skipped it.
Oh, but then it says you cannot come back, and that's what the problem was.
Yeah, but then even though I tried to turn in my assignment, it doesn't say I turned it in. I think I'm not quite sure.
That I'd have to look at separately. But you
I had the same problem also. I'm not sure if mine got submitted or not.
Yeah.
It would take me too long right now, but if you want to wait to the end, once we've finished, I can, I have to do a menu inside a menu thing. I'll find out if your stuff is there, and if it's there, then everybody's happy, right?
Okay.
It normally takes each question totally separately. So, the worst case scenario, only one of your questions never get recorded. But if you've done anything else, it will have been recorded. I know it does that. Right. And you had a second question. What was that, Jamila?
It's on the homework 2 on question 14. Because for some reason, when I did the math, I got the graphing right, but then I got the boxes wrong.
Okay. So this is number 2, question
14.
14 again. So I'm about 14.
And I even wrote down how my problems.
I think I kind of figured it out. I think it kind of just submits it separately. It's like part 1, part 2 kind of question.
Huh. Okay.
Because on my end here it says both of my answers on x-intercept, y-intercept had a check mark on it, and so is the graph. So
But for me, I only had the graph one.
Did you fill in these guys up here?
On mine, where is it? I did fill those in, but then I got those both. I think I got both a wrong or one wrong, but then I had a weird check mark thing because I sent an email. Hold on, I'm trying to find it. Sent. It says when I submitted the answers. Uh-oh. Sorry, I'm trying to open up the picture. It said your answer cannot be understood or graded.
Oh, I don't know what that is.
Because I put a 5, 0, and then the other one is a 0, -8.
Well, it may be that you just got the answer wrong. It could be simply it's not 5, maybe it's -5. Right. And one of the things that WebAssign does is it makes these random, so that your question won't be the same numbers that I've got in front of me here. That sounds to me like something that's probably easier to do at the end, where we can share screens and I can look at what you've typed.
Okay.
Okay. Apart from that, are we good, guys, to start the next topic? Didn't really help too much, but sometimes I help more than other times. Okay, well, let's get started with how to solve equations algebraically. Well, drawing all these graphs, even with the help of software, is fine, but there are some circumstances where the graphs are just too big. Can you imagine there's a line over here and there's another line miles away? It just isn't practical to draw graphs, or that the coefficients of the x's and y's that are just really ugly and it's hard to be accurate. So what we're going to look at now in homework 4 is how to solve a system of equations. Algebraically. Now, there are two different methods that you can use to solve an equation algebraically. It kind of depends on what the two equations look like, which method is easier or better to do. The first method is universally called the substitution rule, or the substitution method. And the second one has two names. In some textbooks, it's called the addition method. In others, it's called the elimination method. It's not that these two are different. It's the same thing, it just has two different names. There's probably another name for that, and there's maybe another name for that, but I don't know them. I'm just telling you the ones that I do know of that are pretty common. Because it's sometimes helpful, isn't it, if you just go into YouTube and you type addition method or you type elimination method, you'll see some more videos on it and it might be helpful. Right, so it's a good thing to just have a name attached to something. Excuse me. So substitution method, addition, or elimination. So it's sometimes a good idea to have a name so that we use the language and you know what I'm talking about. So let's look at the first technique called substitution method. You should use this method when, so you should use it when at least one of the equations looks like y equals, things like 2x plus 1, or x equals 4y minus 3. So if one of your two equations is y equals the rest or x equals the rest, then the substitution method is the best method to use. So you only need one of them. It's nice that both of them are that form, but one is enough. Okay, and so we are going to look at substitution method first. So as long as one of the equations look like that. If neither of the equations look like this, then we use the addition method. So there's your choices. Right. If one of them looks like this, substitution. If neither of the two equations look like one of these guys, addition method. So let's do one. There's my first equation, y equals 3x minus 4. Can you imagine that might be a straight line looking like that? And the next equation is going to be 2x plus 3y. I'm trying to make this work out nice. So I'm going to call this equation 1, and I'm going to call this equation 2. So y equals 3x take away 4, and the other one's going to be 2x plus 3y equals 23. So what's that? That's a point slope equation and a general equation of a line, right? A bit of A, a bit of B, two things. So let's see how we solve it. You substitute. Y equals 3x minus 1, that's equation 1. And you substitute it into 2x plus 3y equals 23. So you might think, well, how do you substitute this into that? Well, you write this guy down. And then see this y that my finger is pointing at? He gets replaced by that. Because what this is saying is y is equal to this. That means anytime you see a y, you can replace it, substitute it is another word for that, by 3x minus 4. So what I've now got is 2x plus 3y becomes 3 lots of 3x take away 4 equals 23. And can I change this question to a plus just to make the answer easier to deal with, right? So pretend it was always plus, right? Just pretend it was always plus. So 2x plus 3y becomes 2x plus 3 lots of this. And now we're going to do some math that you did in Math 94. What I've got here is an ugly equation, but it only has x's in it. And so I have to go through some algebra. And when I'm finished, I'll be able to tell you what x is equal to. So looking at this line here, what do you think the next thing I'm going to do? In particular,
You
here.
want to go ahead and times 3x with plus 4.
Okay, so the jargon for that, and you're quite right what you said, is you distribute the 3. So 3 lots of 3x gets me 9x, and 3 lots of 4 gets me 12, and the answer is 23. Are we comfortable with that line, everyone? It's called distribute. Okay, I'm taking my time here because we're in no rush. What do you think you should do now, especially with the left-hand side? Is there anything I should probably do before I do whatever comes after that?
Combine the x's.
Combine that. Yeah, combine the x.
I agree. Are you all kind of thinking solving the equation? Now, that's the kind of cap you've got on. I'm solving an equation in x's, right? Now, every step gets you closer to that, doesn't it? Every step gets you a little bit nearer. I have a name for this. It's a totally made up name. You'll not see it anywhere. But when I solve equations, I use a rule called, as long as you do it to both sides, it's okay rule. That's my name for it. And what that says is, look, if you want to solve an equation, as long as whatever it is you do it to both sides, it's okay, it's allowed. So what do you think I'm going to do to both sides to get this a little bit closer to being solved?
Subtract the 12.
Can you see why I changed the question a little bit? Just to make the numbers come out nicer. Now, very often you will be at this point here. It'll be 2x equals 10, 4x equals 40, right? It'll be something like that. And so you're almost home and dry. There's only one more thing to do, isn't there? So what should I do to both sides to get x?
Divide it by 11.
Right. And 11 divided, well, I guess I should write it in because this is notes, but you probably do that in your head. In this particular case, you get x equals 1, didn't you? And so we are half done. Because if I want to solve this, don't I need to know the x and the y value where the two lines would meet? That's what the solution is, right? The x and the y value. So I now have to figure out how to use the fact that I know x equals 1 to find the y coordinate of the solution. So this is the x coordinate of the solution, but I now want to know what the y coordinate of the solution is. Any ideas how I might do that?
Mm,
You would plug in the 1 for like all
Keep
the
going,
x's.
you're right.
So
Do you think I should do it with the first one? It doesn't matter because both will work. But which one do you think I should do it to? Equation 1 or equation 2? What do you think would be the least amount of work?
1.
1.
Agreed, right? You could do it with 2 and it wouldn't matter. It'd work. I'm just saying I don't like doing work if I don't need to, right? So I'll write it down because this is like a template for all of these. So you substitute x equals 1 into equation 1. And so what does that become? Y equals 3 lots of 1 add 4. Y equals 3 add 4. Y equals 7. And after all that hard work, this is probably all that you will write in WebAssign. That. But to get that, didn't we have quite a lot of work to do? Right? So behind a simple answer, there's that. Now there's some of you, I can imagine the temptation, I'd have it myself. I don't want to do all this algebra. I've got this new guy he showed me called Desmos. I want to put that one in and that one in and find this answer and just write it down. Would that work? Yes, it would work. But what's going to happen, especially when we do the final exam and the midterm, you will be asked to solve these algebraically, which means you have to show me the working that would make this happen. And if you've only just done basically the shortcut oh, I'll let Desmos figure out what the answer is, then you're not really going to be able to show me that you know how to do it mathematically. Now, that doesn't mean you couldn't use Desmos to check it. After you've got this answer, couldn't you plug that into Desmos and see if it works? And if it works, you'd say, hey, I got that, you know, midterm question, right? There's 15 points I don't need to worry about. I've nailed them. And if it doesn't work, wouldn't it say, oh, God, that plus should have been a minus, or if I'd got 2, add 3 isn't 6, it's 5. You know, you could go looking for a mistake then, right? Does that, to get the gist of what I'm saying, you need to be able to do this just for pure math reasons, but also because you'll be tested on it and we want you to be good at it, right? So this is a pretty straightforward thing called the substitution method, right? I'm going to do another one that works. By works, I mean gives you a reasonable answer. And then I'm going to start making life difficult because there are 3 things that could happen. Couldn't you get parallel lines? And what would that look like if you tried to use this method? And I'll show you. And couldn't you get identical lines? And what would that look like if you did it? So that you can tell when you've got a single solution, no solutions because it's parallel, or an infinite number of solutions. And this method works for all 3, right? The substitution rule works for all 3. But let's do another one that works first before we start making our life too crazy. I'm just looking at the homework so I can pick numbers at work. It's easier if I let them do it than me. Suppose we had y equals x add 3. I'll call that equation 1. And we have an x plus 2y. And it's going to equal 15. And I'm going to call that equation 2. I want to do something here before I move on. I want to make sure that question is a single solution situation. So if you can bear with me just for a few seconds while I, when was that y equals x add 3? Okay, it works. Now, we are going to, essentially, I'll bring this guy, and I'm going to use that as my template, right? So I'm going to do the same kind of things in the same order. So I'm going to substitute. Y equals x plus 3, that's equation 1, into x plus 2y equals 15, and that's going to be equation 2. And we do that by going x add 2y equals 15, and the y here gets replaced by this guy. So it's 2 lots of x add 3 is 15. Distribute, just like we did here. 2 lots of x gets me 2x, and 2 lots of 3 get me 6. Combine the like terms. Subtract 6 from both sides. And then divide both sides by 3. And we have got the x coordinate of the solution. And now I'm going to substitute x equals 3 into equation 1. So y is going to be 3 add 3, y equals 6. And there's our solution. Was that good? Did that flow nice and smooth? You feel comfortable about this technique, at least as far as it's going?
Yeah,
Feel
I do.
good? Okay. I've got an idea. I wasn't going to do this, but I think it's worth it. Let's give you one to try yourself. Okay. Y equals x plus 4 and x plus 2y equals 20. Okay, you got 3 minutes, no pressure, go for it. Hi, Alyssa, is that your family joining in the question?
Yeah.
Who's
My
the
cousin.
tiny one? Oh,
Oh, that's my cousin.
so did she know how you solve equations as well?
Not really.
Okay. Where's yours, Rachel? Where's your little guy?
He's eating dinner.
Oh, if you feed him, he'll give you some peace. Okay. Right, time up, guys. I'll give you a very quick version of this. Hopefully you've done it, so you're just going to say, yep, I got the same answer. If you substitute this into that, you're going to have x add 2 lots of x add 4 equals 20. You're going to have x add 2x plus 8 equals 20. 3 at x gets you that guy. Subtract 8 from both sides and then divide by 3 and you got 4. Okay, so that's like halfway do. So far, so good? Right. And then you're going to substitute x equals 4 into here. And so that's going to get you y equals x add 4, y equals 4 add 4, and y equals 8. So your solution would be the point x is 4, y is 8. So if you got that, I'm happy. It means that you know what you're doing, right? And what could go wrong? Well, can you imagine that they're not always going to be nice numbers? Sometimes you're going to get a half and 3/4, and that's okay. And sometimes you're going to get -2, and sometimes you're going to get some really weird looking things. But you trust the math. This method doesn't care how ugly the answer is. So do you know the answer could be 7/11ths and 14/19ths, you know, some ridiculous fractions. It's still correct. But if you drew it using Desmos, you wouldn't know it was 17/11ths or whatever, because 17/11ths is a weird decimal, and all Desmos does is give you the decimal answer. It doesn't give you the exact answer. So you wouldn't be able to do you wouldn't be able to always do the Desmos shortcut. Now, what I'm going to show you now is Desmos for a minute. There are the two lines. Y equals x plus 4 is the red one, and x plus 2y equals 20 is the blue one. And if I click on that, there we go. Perfect match. Isn't that nice? You can check really quickly. And Web is saying,
if
say
we
again?
choose not to use Desmos, are we going to be go up matter on the midterm?
Not one bit.
Okay.
Desmos is not part of the thing you must know. You must know how to do the algebra to solve it, right? What we've just done, that I do need to see. But you might want to draw everything by hand. You might not even bother about drawing it, because if you're in the section that says solve it, you don't need to draw anything if you don't want to. Are we good so far? So I said I know I'm about to do it. I want to show you the other two situations. I want to show you what it's like when you try and solve a system of equations and they're parallel. Right? How does this method, what does it look like when that happens? So let's give you an example of it. Suppose y was 2x minus 5. There's my first equation. And you got 3y plus 6x equals 10. And that's my second equation. Now, you very often cannot tell, just by looking, whether or not you're going to get a single solution, no solution, or infinite, right? That's the three things that can happen. You might be, I mean, you're good if you can. You might be able to look at that and say, oh yeah, I can see what that's going to be before I've done it. But most of the time you don't know until you try and solve the equation what's going to happen. And I am going to use my template here, and something's going to go wonky. And I'm showing you what that means when this particular kind of wonky happens. Would you agree that we're going to start the way we start all of these? By substitute the y equals 2x minus 5, that's equation 1, into the other equation. Right? I don't care what the equations are, that's what I'm going to do. I'm going to substitute the y equals 1 into the other one. That's fine. So here we go. Nothing too strange has happened yet. 3y becomes 3 lots of 2x. Have I done that right? I always shoot in space. I can fix it. Caught it in time. Can you pretend that's y equals negative 2x minus 5? It should have been all the time, right? So I've corrected this question. It should be y equals negative 2x minus 5 all the time. So it's going to be 3 lots of minus 2x minus 5 plus 6 lots of x equals 10. Now we'll distribute it. 3 lots of that are negative 6x. 3 lots of that are negative 15. Add 6x equals 10. So far, so good. Now, the wonky, weird stuff. If you take negative 6x and combine it with plus 6x, don't they cancel each other out? And what's left? Negative 15 equals 10. Hey, that's a bit wonky. Negative 15 equals 10? That's stupid. Negative 15 is not equal to 10, ever. Great. So what does that mean? How do we interpret that? Well, if this happens in substitution, it means that you've got parallel lines. So all the x's disappear and you've got a number here and a different number there, right? Something that can't be true. That's parallel lines. And when that happens, the answer is no solution. And the way that we interpret that is, isn't negative 15 never equal to 10? And so the only way that that could happen would be the two lines are never equal to each other, right? So are we okay with wonky version number 1? You try and solve it, the x's disappear and two numbers that are not the same number are left. That means parallel lines, so the answer is no solutions. So the last possibility is identical lines, right? The same line on top of each other. Now, when that happens, won't you get an infinite number of solutions, right? If one line is the same line as the other line. So let's suppose we had y equals 3x plus 1. And 2y take away 6x equals 2. And we'll make that the second line. I'm going to substitute. Y equals 3x plus 1, that's equation 1, into 2y take away 6x equals 2, that's equation 2. So I have 2y subtract 6x equals 2. The y gets replaced by this. So I have 2 lots of 3x plus 1, take away 6x equals 2. That gets me 6x add 2, take away 6x equals 2. And something wonky happens here. The x's disappear again. But what's left is actually correct. Isn't 2 equal to 2? Of course it is. It's 2. They're both 2. They're equal, right? That's the wonky version for the same line. It's always true. And always true means that you have one line. And so that is an infinite number of solutions. Now, if I put this guy and this guy into Desmos, do you know you would see one line? The first line would be red and then the black line would draw right on top of it and you'd only see one line. And that represents equivalent lines, right? Infinite solutions. So you'll either get an X that then leads to a Y, right? Cool. Or the X's disappear and two numbers are not the same number. So that's silly. That doesn't happen. You know, that can't be true. So there's no solutions. Or the X's disappear again, but what's left is the same two numbers, right? That's 10 and this is 10, in our case, 2 and 2. And when that happens, you're going to realize that it's an infinite number of solutions, because when that happens, you've got the same line on top of each other. And that's pretty much everything that could happen with two lines, isn't it? They cross, they're parallel, or they're the same, right? That's all you can get. They cross, this guy, they're parallel, this guy, they're the same, this guy. Any questions about that before I move on? That's a good sign, isn't it? No questions is a good sign, right? That means you're happy, right? You feel good about what we've just done. I'm putting words in your own mouth, but that's the case. So I am going to show you a version of question 4. And it doesn't look right because it isn't. but they have forced me to do something. In question 4, here is our system of equations. And it says solve by substitution. Wait a minute. One of those guys should be y equals, or one of those guys should be x equals, and they're not. Because that's what I need, don't I, if I put one of my template questions down. Yeah, this one, right? Don't I need a y equals, or I haven't done it yet, but don't I need an x equals, one or other? And I don't have that. This, in fact, would be a question that you should probably use the addition method on. But if they want me to use the substitution method, I have to do it, right? Because that's what they're testing. Can you take a question and use the other method on it, right? So I need to figure out how I'm going to get this fella to look more like these fellas. And I'm going to take equation 1. Well, I don't need to, I could pick either, but I'm going to take equation 1 and I'm going to play about with it. As long as you do it to both sides, it's okay, right? I can do anything I like to an equation, as long as I do the same anything I like, right, to both sides. I am going to add y to both sides. So mathematically, isn't this the same thing as that? It's just a different looking version of it, right? I took this equation and I added y, so it disappeared, and I added y, and it's here. Now you might say, well, why? How will that help? Well, there's my new equation 1. Here's my untouched equation 2. Put a little ziggy-zaggy line just so that we can separate them out. Can't I solve this now using the substitution method? Because don't I have one of my equations as y equals or x equals? See, it's this one, this is x equals. So I'm going to put, substitute, x equals 3 plus y, that's equation 1, into 2x plus y equals 12, which is equation 2. So here's 2x plus y equals 12. It's going to be that guy that replaces him. So it's going to be 2 lots of 3 plus y, add y equals 12. It's going to be 6 add 2y plus y equals 12. Combine the y's together. Just pause for a minute because I write fast. Are we comfortable so far? It's a kind of, turn the handle process. You do the same thing over and over again. What's the next thing that I should be doing to both sides to solve for y? What's the next one?
Combine the y's.
Okay, done that. It's 3y. So what do I do now?
Subtract 6 from both sides.
with 6.
Yeah, I think one of you was about to say the same thing. Okay, what do I do next?
Divide both sides by 3.
And bingo. Haven't we found that y is equal to 2, right? We've got half the answer. Normally you find x, and then once you know x, you can then find y. But it works both ways. If I find y first, can't I use that to find x? So how am I going to use that to get x? Well, I'm going to substitute, put y equals 2 into this equation here. And that's going to be x equals 3 plus 2, and that's going to get me 5. And here's my solution. And remember, the x goes first and the y goes second, right? So 5, 2 is the answer. Even although I found the 2 first and the 5 second, the first number is always the x coordinate, right? And the second number is always the y coordinate. Are we comfortable with how we took this question and tweaked it so that we could use the substitution method on it? Are we good? Right. I'm not going to do the whole question again, but I want to show you that question and looking at it a slightly different way. Maybe this was the way you were thinking about it. Here is the original two equations. And I took this equation and changed it. You know, I could have taken this one and done the same thing. So let's see what it would look like. If 2x plus y equals 12, if I subtract 2x from both sides, don't I now have my y equals that I was looking for? So my equations would have been y equals 12 take away 2x and x minus y equals 3. I just swapped the order. And you'll have to trust me on this. If you use this pairing, will you trust me that you still get 5 and 2, right? Algebraically, algebra doesn't care if you go x's and y's or y's and x's. It doesn't care because it's the same problem and it's the same answer because of that. Are we good? Hold on a moment. My dog was telling me there was a leaf floating by or something. It's his job. He has to protect the house from everything. It's a real pain in the butt, but we love him. That's me finished with the substitution rule. There's really not much else I want to do with it right now. Later on, I'll do some fractions and some ugly stuff, but right now that's a good start. Is there anything about it that you want me to go over before I talk about the second method, which is the addition or elimination method it's called? This is your chance. Any questions? We feel good? Okay. So if you have, bring this guy back a minute. If you have a situation where one of the two equations is of the form x equals, oh, it's in front of me here. If you have a situation where at least one of the equations is the form y equals or x equals, you know the substitution method works really well, right? That's the ones that we've just been doing. If, however, neither equation is in the form y equals or x equals, then I'm going to call it the addition method. I don't want to keep jumping between two names, so I'll just stick to one name. Then the addition method should be used. Of the two methods that we typically use to solve systems of equations algebraically, the addition method is by far the most common, right? In other words, if you just randomly went into a math book that was dealing with this, I would put a guesstimate of about 2/3 of the questions would be the addition method, and only 1/3 of the questions could you use the substitution method, right? So the addition method is much more versatile, right? It can basically take care of any equations that you've got, whereas doesn't the substitution method require one of the equations to look like this? And that isn't always going to be easy to do, or even wanting to do it, because that would be really ugly if I tried that. Okay, so how does the addition method work? Well, there is a clue in its name. You're going to add some things together. You're actually going to add the two equations together. And we're going to start off with very simple ones where you don't need to do anything. And then we'll gradually get to more and more complicated ones where there's more and more things to do. But let's start off with the simplest case. So I'll call this example A. The simplest case is you don't need to change anything. If you're really lucky, that's one you'll get. So you might say, well, what do you mean you don't need to change anything? Here is an example. And you just have to wait a few moments while I figure out a solution that's going to work. I'll take a piece of paper. Two lots of four. Right, here we go. Now, if you were given that system of equations, would you agree that you do not want to try and turn any of those into an x equals or a y equals? Can you just imagine how darn ugly they're going to be? And then when you substitute it in here, isn't it probably just going to get even uglier? I guess theoretically you could do it, but in practice, nobody would ever want to, right? So can you see there is a need for another method, right? System of equations. So make sure that your equations are so many x's plus or minus so many y's equals a number. So just make sure that they're in standard form. And pretty much that's done for you in the vast majority of questions. But just in case, occasionally they get sneaky and they shuffle them. Now, do you notice that there's a negative 3y and a plus 3y? You are allowed to add equations together. So if you draw a little line and another little line, and you put an equals in here, you add these two together, you get 25. Now, if you add this equation, which is 2x, to this equation that's got 3x, would you agree that when you add them, you get 5x? What do you get when you add or combine negative 3y to a plus 3y?
0.
They cancel out.
They cancel out. You don't even write 0y. The convention is math is if the thing's 0, you probably just don't do anything, right? You just leave it blank, right? It's gone, cancelled out. Oh, wait a minute. Don't I have an equation that only has x's now? Isn't that clever? So what do I do to both sides to find out x?
Divide it by 5.
And we have just found part of the solution. Don't we know x equals 5, right? That happened, you know, when we did the other method. And so now I'm going to take this piece of information. I'm going to substitute x equals 5. And how did I phrase it? And put it into, oh, okay. Now, when it was the substitution method, wasn't there a nice equation up here like y equals 2x plus 1, and I put it into that? In this type of situation, we have two equations. And we know that x equals 5. So do you think I'm going to plug it into equation 1? Or do you think I'm going to plug it into equation 2? Or do you think it doesn't really matter as long as I plug it into one of them?
Doesn't matter.
Doesn't matter, right? Doesn't matter. You're going to have to trust me on this, but you'll get the same answer, right? You'll get the same value of y no matter which one. But it's not really a rule, but I'm lazy. Which one of those two equations do you think I'm going to use because I'm lazy?
3x plus 3y.
And tell me why I'm going to do that, because you're right.
Because you're adding instead of subtracting.
And isn't minuses where people, including me, tend to get missing? And you have it and you lose it, or you forgot it, or whatever you want to call it. And somehow or other, I just screw things up more often when there's a negative or a subtraction involved, right? So that's the only reason. And it's not a big enough reason for me to say, you must do it this way, because you don't need to must do it this way. I just choose, because my experience is I screw up more often when I use number 1 than when I use number 2. So I'm going to plug it into 3x plus 3y equals 21. That's equation 2, right? Have I convinced you that it's worth remembering, or do you think, I'm not that bothered? I don't tend to do the mistakes he does. Right, so x is 5. So 3 lots of x becomes 3 lots of 5. Add 3y equals 21. 15 plus 3y equals 21. Subtract 15 from both sides, and then divide both sides by 3. And we have our solution. And our solution is x is 5 and y is 2. Do you like the addition method, at least this simple version?
Way easier.
It is. Don't expect them all to be this easy, because we're starting all simple and getting ugly. But you very often don't have a choice, right? It depends on the information. Sometimes it's written this way, right? And so it's going to be the substitution method, right? There's no way of avoiding it. Sometimes it's going to look like this and it's the addition method, right? And there's no way to avoid it. But it's a nice method, right? Does it kind of make sense that it has a logic to it? It's not too weird. Right. Now, at this point here, I'm going to do some more simple examples, because I want to show you the same 3 situations that happen when 2 lines meet. Haven't we just found the 2 guys cross? If you use this method and they're parallel, what will it look like, right? What will the math look like when the 2 equations are like this? And lastly, what will it look like when they're identical? Okay. So I'm going to choose each of those situations, right? A pair of equations that are parallel, that's my next one. And we'll see what the math looks like, so that when it happens, you're going to say, that means a parallel, no solution. And then after that, I'll do a system of equations where the 2 lines are identical, and show you what the math looks like when you try this method. Okay, so here is B. Still a simple case, so we don't need to do too much work. But I'll put the word parallel beside it, just to remind us, this is, right, 2 parallel line situation. But that shouldn't be too much of a problem, you would think. Yeah. Okay. 2x, take away 4y equals 10. That can be equation 1. Negative 2x, add 4y equals 20. That's the same equation. So here are 2 different straight lines. I mean, they look quite similar, but technically they are different. If you put them into Desmos, you would see 2 parallel lines, if they trust me on that. So would you agree they're good to go? You can add the y's together and they disappear. Actually, can you add the x's together and they disappear? Because sometimes it's the x's that disappear and not the y's. So you add them. I guess I should put that over here, because when you go and look at your notes, you're going to say, I wonder what I did. And the answer is you added. So I add them. I get nothing, and I get nothing. And I get equal 30. Oh, that's weird, isn't it? Is 0 equal to 30? Never.
So no solution.
No solution. And doesn't no solution mean parallel? Agreed? No solution equals parallel. So no solution. So what does that mean? It means that if you do the addition method and all the variables disappear, right? The x's disappear and the y's disappear, right? So all that's left with numbers if the two numbers are different, don't you have no solutions? Actually, isn't that the same thing that happens when you use the substitution method? Don't you end up with two numbers that are not the same number, right? So algebraically, it looks pretty similar to what happens, no solution. Have you I guess what the last situation is going to look like? Both numbers are different here. What do you think identical lines are going to give you?
Same solution.
Yeah, infinite solution. And isn't it going to give us the same numbers then, same solution, same values? So let's show you that one. It's on a simple case. So, and we'll call this identical. And this is going to be 3x plus 2y equals 5, negative 3x, negative 2y equals negative 5. I know they don't look that dissimilar, but if you want to keep it simple, you can't really change too much. And those are equations are very similar looking, but they are different, right? There's negatives instead of pluses. When I add these together, the x's kill each other off, the y's kill each other off, so you've got 0. But don't the numbers kill each other off? So when you do the addition method, do you see that both sides end up being the same number, in this case 0? And that means identical. Right, that means same line twice, right? And that is infinite number of solutions. That guy that looks like an A on its side is the symbol for infinity. Right, that's infinite number of solutions. So far, so good? Right. I'm going to give you one example of the addition method, a simple one, and it will be one of these three situations, and you're going to try and solve it, and hopefully you will solve it. And it's a way of just, you verifying yourself that you're comfortable with the process. So I should probably put one of my examples up here. Okay, then that one can be my template. So 3x plus 2y and 7x minus 2y. This can be 15 and this can be 5. So solve that system of equations using the addition method. You've only got 2 minutes. Go for it. Okay, let's go for it. If you add these equations together, 3x added to 7x gets you 10x. Won't the 2y and the negative 2y, when you add them, combine them, kill each other off so they cancel out? And the two numbers, when you add them together, get you 20. And that gets me, divide both sides by 10, that gets me 2. So hopefully you got the first part, right? X equals 2. And then you substitute x equals 2 really into either one, but you know I like the plus version typically, so I'm picking that one. So into 3x add 2y equals 15. That's 3 lots of 2 add 2y is 15. That's 6 add 2y is 15. And that gives me subtract 6 from 2 sides is 9. Oh, I just realized our first fraction. Now, 9 halves, right? You divide both sides by 2 and you've got 9 halves. You might have written 4.5 and you might have written 4.5. Agreed? So I don't know what you did. Hopefully you wrote 9 halves. Even if that looks the ugliest of the three, mathematically, we like fractions to be written in that format. They're called improper fractions in America, right? So ugly name, I don't like it, but that's what it's called. 4.5 is correct numerically, but if you try it in WebAssign, it's probably going to go wrong, right? And you're going to scratch your head because you know you're right. But 9 halves. 4.5 is a little bit more flexible. WebAssign might take it, it might not. It depends if it's a Monday or a Tuesday. WebAssign is sometimes very quirky about what it does and what it doesn't do. 9 halves. That is the improper version. I like names of things to at least give you a fighting chance to tell you what they do. So let me give you a little story. This is not a made up story. This is true. We don't call them improper fractions back home. I mean, that's what you would call them in America, improper fractions. We have, I think, a much better name. They are called top-heavy fractions. Doesn't top-heavy fraction give you a better idea of what the blinking thing looks like? Because when you see the word improper fraction, it somehow sounds like it's wrong, right? It's improper. It's not really what you should be doing. I'm a great believer things should be given names that kind of help you, not hinder you. So I like the name the addition method. And I like the name addition method because doesn't that give you a clue that you're adding things? Right? The name gives you an idea of what you're doing. The other name for this is the elimination method. I don't like the name elimination method. Right? That's a name for this because it's not so obvious what you do. You see addition method, it's kind of obvious what you're doing. Elimination method's the name, but do you know what you're doing? We need a joke before we start moving on to more complicated versions of the addition method, right? Has anybody got a really bad joke for me?
I do.
Okay, hold on a minute. Who said? Oh, Jamie Lynn, go for it.
It's really short. It's really short. I just looked it up just now.
Go for it.
Okay, it's a math joke. So there's only a fine line between a numerator and a denominator.
Oh.
And then it says only a fraction of people will get this.
Oh, I like the punchline. That is.
It's a bad joke, but.
Oh no, I love bad jokes. I think the worse a joke gets, I think jokes are like a circle where you start it good and they go bad. But I think if you go bad and then you go really bad, don't they become good again? So a really, really bad joke can actually be quite good. I like that one. Someone told me a joke today in one of my calc classes, so here goes. Why don't ants catch COVID?
What?
Why don't ants, A-N-T-S, why don't ants catch COVID?
Because they have antibodies.
Yes, they've got antibodies. Oh, come on, that's cute. No? Oh, I thought that was good. Oh, God, who have I not picked on? Oh, let's pick in Canada. I said we'd do jokes. So has anybody got a joke? And then I'll tell you a couple of Canadian jokes. And then, because I think I need a little break just to give my brain a chance to, assimilate the information. Anybody got any jokes? Okay, so you know what I'm like. So next week when I see you, you're going to have your own little joke, right? Just, Rachel, check for your wee fella. He's probably got a joke for you, right? So this guy is walking down the street. This Canadian is walking down the street, and he's got a big crate of beer on his shoulder. And his pals across the street sees him, and he's happy. He's walking with a big smile on his face, so it's great beer. And his pal sees him, and he waves at him, and he waves back. And his pal says, "What's that you've got on your shoulder?" And he looks at it and says, "Oh, it's a crate of beer for the wife." And his pal said, "That was a good swap." Dawn, I'm going to have to take a picture of your face. Every time I tell a joke, it gets worse. It's, oh God, he didn't do that one, did he? Right. Canadian joke. Do you know that Canada wasn't always called Canada? Not a lot of people knew that. Canada used to just be called that country to the north of America. Right? People would talk about it, say that, that country to the north of America. So the Canadians get fed up, and the Prime Minister of Canada gets on the television and he does a big spiel about it. Says, "Look, we're fed up. We're going to have our own country's name." And he says, I'm not going to do one of those big committee things. I'm just going to do it live on TV. He's got a big bag in front of him. He says, "I've got letters of the alphabet in here, lots of them. And I'm just going to stick my hand in and I'm going to randomly pick out letters. And whatever combination of letters comes out, that's going to be our country's name." So he goes in and he brings out the first letter and he goes, C, A, N, A, D, A. Bailey, come on, let that one sink in. Nothing.
I have family in Canada, so I think it's
It's
funny.
the accent. I get it.
Yeah.
Oh, you got it. They say, evidently, they say A a lot. Rachel, you got family in Canada, do the A a lot?
Oh yeah, they make fun of us, and there was like they say that we say y'all a lot, and then they always say A, so I always had jokes about that.
I never say you all, ever. Do some of you say you all? Texans say, right, that
I'm
part of
from the East
America.
Coast originally, so that's why.
Oh, okay.
Yeah.
Right. I guess they do. Okay. You want one more Canadian joke and then we can get started? Because I figure out if I tell really bad jokes, you'll want me to start doing math again, so I'll stop. So it's kind of incentive to get you to want to do math. Don's nodding, yeah, please, can we get back to doing math? Okay, my very quick joke. What is the difference, right, between a Canadian and a canoe? Don't know. Canoes can tip. That was told quite a few years ago by someone who worked in a restaurant as a server. Evidently, I don't know if it's true, but evidently Canadians are not very good at tipping. And that's the gist of that joke. Did you get it? It wasn't that funny. Okay, I can't win all of them. Actually, I think Don liked that one. Go figure. You never know. are we now ready? I think we are, to continue with our work. So we've looked at solving using the addition method in simple cases. We're now going to do a more complex case. And this is where you need to change only one of the equations. So after we show you situations like this, there's another situation after that, which will be even more complex. And that's like the ultimate version of the addition method. And that's going to be where you need to change both equations, right? So you don't need to change anybody, right? If you add them, it works. In this case, you're going to have to change one of them. We'll see what that means. And then it works. And then after that, the last situation is you need to change both equations before this method will work. So let me show you an example of that. And I'm going to do my little cheat at the side so I can get one that works reasonably well. That's going to be 3. And that's going to be 18. Okay. So let's see what the problem is here, because they're not going to tell you that it's a more complicated one. They're just going to say solve it using the addition method. Can you see what the problem is if I try to add these two together? Nothing gets killed off. Won't you just get 6x and 3y? Nothing gets killed off. Now, when I added these, don't the y's kill each other off? But can you imagine a question where the x's might disappear instead? Right, that could happen as well. What you need to do in a situation like this is to recognize that although this equation and this equation right now don't destroy each other, it is possible that if I change one of the equations, in this case, I'm going to change equation 1, I could turn it into something that could work with equation 2. So let's see what my problem is. Do you see how that's got 6y, but this has only got negative 3y? If this said negative 6y, couldn't I add them? Right, if this equation here had a negative 6y in it, wouldn't the method work? So how am I going to make that happen? Well, I'm going to multiply this equation by 2. And as long as you do it to both sides, it's okay, which means you can double that, you can double that, and you can double that. So this was the original question, which we really couldn't do much with. And by multiplying only the first equation by 2, do you see that we've now turned it into a much nicer equation? Would you agree that that equation will work with the addition method? Right, when you look at it, can you see it working with the addition method? Right. I'm just going to write it again over here. So the new equation 1 is that guy. Equation 2, oh, there's no reason why they're the same, they just happen to be. And now I can add them. And 4 and 4 get me 8x. The 6 and the negative 6y kill each other off, so they cancel out. And 6 and 18 gets me 24. That's good news, isn't it, when that happens? Right. Can you see where I'm going to go next? Okay, what should I do to get x then?
Divide both sides
by
up by 8.
By 8, yeah. Agreed? So we now have Oh, Rachel, you can tell your Canadian friends that joke about the canoes.
I will.
Okay, so we got x equals 3. Are we happy about that? Where do I go now then? You remember what we do next?
You're going to put that into one of the equations.
You
To get
nailed
y.
it.
Into the 4x plus 6y.
Have I convinced you the positives are nice? Because I don't need to convince you. I mean, it's not a major issue, but you know, I find it helpful. So I'm going to substitute x equals 3 into this one, which is what, equation 2? Right. So 4x plus 6y equals 18 becomes 4 lots of 3 plus 6y is 18. We get that. We can then subtract 12 from both sides. And then we can divide both sides by 6. And we get our solution. And it's x first, comma, y second. Right? And that's us. That's all you probably write in WebAssign, right? That little thing there, even although it took all this work. So get used to writing a lot for very little at the end. Are we good? Right. Suppose I did this method and I doubled one of the equations or whatever it needed to be. Suppose I did that and the x's and the y's disappeared and that's what was left. Right? It could happen. Right? So I did the addition method, I doubled this, the x's disappeared and so did the y's, and I was, well, it's probably going to be a 0 there, but whatever. 0 equals 12 was left. What would that mean? What would the answer be?
No solution.
No solution. I did it and 0 equals 0 happens. What would that mean?
Infinite.
Right. So are we cool where infinite and no solutions can happen and what it looks like when you use the method on it? I was just doing a quick scan. They do quite a few no solution ones towards the end of this homework. So they don't seem to happen at the start, so you won't see them for a while, but towards the end, you know, the last 5 or 6 questions, there's at least half of them are no solutions when you do them. So hopefully that won't be a shock where, hey, how come that one didn't work? Oh, and the next one didn't work? Oh, come on. And the last one didn't work? You know, you might talk yourself out of the answer because of that, right? It is what it is, right? If the math says there's no solution, there are no solutions, and we trust the math. Okay. Now, I'm going to do another one of these. And then after that, I want to do what you would change, which equation you would change and what you would multiply it by. So not the whole question, but just like the beginning of it. But this one, I'm going to do the whole thing again. So let's do 5x, make that negative 10x, plus 3y, minus 4y. I'm trying to make the numbers really messy and ugly. Okay, there we go. I think this one will come out quite nicely. Yeah, I'm looking at this pair of equations. And if I tried to add them right now, would you agree it wouldn't work? The x's wouldn't kill each other off, the y's wouldn't kill each other off. If you look a little bit closer, wouldn't it be easier to kill off the x's in this case? And isn't it 5x if it was 10x? Wouldn't they cancel quite easily? Wouldn't it be much more difficult to make the 3's cancel out this guy?
So multiply it by 2.
So multiply it by 2. And so what you've got is 10x add 6y equals 20. Don't do anything to the other equation because in this particular world, only one of the equations needs to be changed. So I'll do a little squiggly line so that we can separate that. So now we're going to solve this system of equations instead. Would you agree that it's ready for the addition method? Right, we can add them right now and move on. So let's add them. These two, when you add them, actually cancel each other out. These two, when you add them, you get 2y. And these two, you get 22. Everything good? You happy? Okay. Divide both sides by 2. And we have got one piece of the solution. And now I'm going to substitute y equals 11. And I'm going to substitute it into, and it shouldn't be a guess. I think most of you know which one I'm picking. Would that probably be the one you would have picked as well? Yeah, less negatives, less mistakes, right? So I would plug into this one. Could I plug it into this one? Would it work if I plugged into this one? Yeah. Would it work if I plugged it into this one? Yes. So it's not a prescriptive thing, right? Just find any equation that you like, right? Any one that you like that's got an x and a y in it at least, and it'll work. So 10x plus 6 lots of y equals 20. Ooh. 10x plus 66 equals 20. 10x, I should have thought this one through, negative 46. And now, actually, it's kind of good that this happened. I didn't plan it to happen, but it's kind of good. Normally, all you would do is that, agreed? What you call improper, what I call top-heavy fraction, right? But there is a rule about fractions. Shouldn't you simplify them as much as possible? Can 46/10ths be simplified, even if it's just a little bit? Agreed? What would you do to the top and bottom to simplify this fraction?
Divide by 2.
And so that is, you finished. So our solution will be negative 23/5 11.
So if something like that happened in the homework, do we have to
Yes.
simplify it, or is it okay?
Yeah,
with
you
the
must
solution?
simplify it. WebAssign will say you're wrong if you don't. So if you plug this in, it would say you're wrong. And what would happen is you'd probably think that you've screwed up somewhere important and you've done something, you know, really weird. And it's not. Couldn't it simply be you just didn't realize that you could simplify it? I mean, sometimes the simplest mistakes are the hardest to see, right? You know, 4/6 looks fine. It's actually, it should be 2/3, right? But doesn't it kind of look okay? It's not that weird looking. And so you don't notice it. So always think about simplifying the answer before you go looking for really, you know, major mistakes that you may have made. The most common mistakes that people make in questions like this is not simplifying the answer, losing or gaining a negative. In other words, you put -2 and the answer should have been +2 or the other way around, right? You lose or you gain a negative. That's quite a common mistake as well. So look out for those guys before you start having to redo the question. Now, I know you get 5 shots, and that's helpful because it means that if you make a mistake, you have plenty of room to find out what you did wrong and try it again. But don't start doing any major trying it from scratch until you've checked all the obvious little things that you could have done, because it might be something simple. Are we cool with that, guy? Kind of like that one. I didn't expect that, but that's okay. I'm looking at the homework solutions right now to this section that you'll be doing this to. 13, 14, for instance, have some ugly fractions in them. So you are going to get ugly fractions. In fact, those two questions, 13 and 14, both the X and the Y are fractions, right? So don't freak out if you say 3/4 and 7/8. That doesn't look good. It's probably right. You know, some solutions are there. So we are looking at the last situation here, as far as methods go. And I'm trying to find what I've called the damn thing to be consistent. Oh, there we go. The last situation is even more complex. These are not official names, but right. This is the hardest one to do, obviously. This is when you need to change both equations. Okay. And can I just pause for a minute? I jumped ahead of myself. We will be doing that, but I promised that we do some examples of practice at changing these, right? Not doing the whole question, but just practicing, right? Okay. Here's equation 1, here is equation 2. Which equation will I multiply and by how much to be able to use the addition method? So which equation and by how much?
You would multiply 4 times 3 and then the 3 times 4?
Oh, you are jumping ahead, young lady, and that is good. You're thinking of solving this. But in this question, we're still on this situation. So you only need to change one equation, not both.
Oh,
So what single equation? Yeah, go for it.
2 by 6? No,
Nope.
that's not right.
Think again.
By 3?
Would you agree multiplying the first one by 3 would work? Because wouldn't that get you negative 6y plus 6y? Okay, let's look at this one. What would you multiply equation 1 by? Or equation 2, whichever one you think needs to be changed, so that you can use the addition method this time.
Negative 2.
Do you need a negative or will 2 work?
Oh, just regular 2, sorry.
Just a regular 2. If you multiply this by 2, won't you get 6x and it will cancel out with the negative 6x? Essentially what you want is the same number of x's or y's, one to be positive, right, and the other to be negative. In this question here then, which equation would you multiply and by how much so that you could use the addition method?
2.
And equation 1, I'm assuming, right? By 2?
Yeah.
Yeah. Are we comfortable, or you want to see some more of these before we move on? You good? Okay. Right, let's move on now, because I did jump ahead and look at even more complex. I guess I forgot the word complex. This is where you need to change both equations. And yeah, This is what we're going to be spending the rest of today on. So there's equation 1. Pause with me for a minute. And just check on that. Check. Right. Okay. What makes these the hardest is that there isn't a normal number, right? A normal number, I just mean a times 2, a times 3, right? We don't want to talk about weird fractions. That never works well. I can't really change this equation and it works with this one. I can't really change this one and it works with that. And the reason is that the way the numbers work out, can you see that nothing's going to kill off anything easily? What I have to do is I have to change both equations to get them to fit. And what I mean by fitting is I want plus 10x and minus 10x. I want plus 6y and negative 6y, right? I want one equation to have the same number of x's or y's as the other. And I also want one of them to be a positive amount and the other to be the negative. Now, when I look at these equations and I realize that it's the worst case scenario, I focus on just one of the variables. In this case, I'm going to focus on the y's. And I think to myself, okay, if I'm going to have to change both of these so that they fit, right? So one of them's like plus 9 and the other's minus 9, whatever it's going to be, right? I have to then figure out what to multiply them by, right? And it's not as hard as it seems. I'm going to multiply this guy by 2, and I'm going to multiply this guy by 3. Now, I didn't bring those numbers just out of the mid-air, right? Guessed, right? Because guessing's not a good idea. Can you see what's going to happen if I do that? Aren't you going to get plus 6y and minus 6y? Do you know where the 2 and the 3 came from? You know why it's not 5 and 7 or 9 and 8 or whatever? Why is it 2 and 3? And where did they come from?
So why?
Because they came from the other y, didn't they? Do you notice that's 3 and you multiply it by 2 and that's 2 and you multiply it by 3? Did you see that? So it's not that hard, is it, to decide what to multiply each equation by? Don't you just multiply it by the other coefficient, right? Now, since I've decided to do that, I'm going to get 4x add 6y equals 32. Would you agree that's what you get if you double all these? And then if you multiply everybody here by 3, you get 15x, oops, minus 6y equals 21. And let me double check I did that right. 6 add. Okay, I should have checked. 6 add 12. Can we pretend that was always 18? In which case this becomes 36, right? Now it's going to work out. So you multiply this equation by 2 and you get this guy. So that's going to be my new equation 1. And then I had to change the second equation and I multiply everybody here by 3 and that's going to be my new equation 2. And I just build a little invisible wall. It helps me mentally to separate the two out. Now, is this good to go? Can I use the addition method on it now? So I will add. And these two get me 19x. These two cancel out. And those two, when you add them together, get you 57. Now, shouldn't the next line be divide both sides by 19? And that looks scary, but it isn't. Do you know what 57 divided by 19 is? And if you don't you just go to your calculator and find out? but does anybody know what that is?
It's 3.
It is. Do you know when that happens, when you get a nice number, it's a really good sign you've probably done it correct. You agree when you get a nice number like that out of some really ugly numbers, it tends to be correct. Right, I now have x equals 3. Right, I've got part of the solution. I'm now going to substitute x equals 3 into any particular one you like. I know which one I'm picking, but you can pick any of them because they all work. Which one am I picking?
Easy.
The positive.
Yeah, I'm picking it because it's full of positives and I don't tend to screw up. And do you know the other reason I'm picking it is because it's got smaller numbers. So I figure out I'm less work and I might not do it wrong. That's my hope. So 2 lots of 3, add 3y is 18. 6 add 3y is 18. If you take away 6 from both sides, you get 12. And then you divide both sides by 3 and you get 4. And we now have our solution. X is 3 and y is 4. You're happy there, Rachel. Is it because of what your kids are doing, or do you happy because you like the method?
I'm happy because I get it.
That's a good feeling, isn't it? When it makes sense. Yeah. That I've got a method here that I feel I can live with, right? It's not like a mystery and I don't know what I'm going to do from one question to the other. One of the cool things about what we're doing right now is that it's a process. If you can learn the steps, do this first, then do this next, and then finish with that, you're probably not going to have too many problems. You may have some issues because the numbers are ugly, you know, because sometimes you're going to get 3/4 and 5/7, and that tends to be a bit messy. But it should come out quite nice. Of course, 1 is not enough, right? We need to do more practice before I feel good about that. But it's nice that you feel good about it. Can I pick? Yeah, I'm just randomly picking a question. Oh, that's for later. Oh God, I'm going to have to pick my own. That one there, which I will do next actually, has some fractions as the answers, but I don't want to do a fraction as the answer yet. So let's do, let's see if I can catch it out. That's not very nice of me, is it? Okay. Now, you can choose to always take care of the y's. If you want a rule, it'll work. You could choose to always take care of the x's because you want to. You could choose just to mix and match it. Sometimes I'll take care of the x's. By that I mean you want 17x and minus 17x, right? Or you want plus 4y and minus 4y. You're going to have to change both equations, so it really doesn't matter. Do you want me to get rid of the x's or the y's? Just to show you that the method works both ways.
The x for a change.
Yeah, let's do it for the change. So I tend to cover up the guy because it just distracts me if I see it, right? Now, do you notice I've got a 4x and a 3x? Now, the rule is multiply this guy by 3, right? And multiply this guy by 4. Agreed?
Yep.
But I have to tweak it a little bit. If I do that, don't I end up with plus 12x in both cases? And I can't have both pluses. Don't I have to have one of them negative and the other plus? So let's tweak it. Which one of them do you want me to tweak so that I get a negative 12 out of it? The top one or the bottom? One or two?
The top one.
Okay, now to do that, don't you just make it -3? So instead of multiplying just by 3, do you see sometimes you're going to have to do a -3? Right? Half the time you won't need to, the other half you probably will. So I'm going to multiply everybody here by -3. So that's -12x, -6y, -54. And that's my new equation 1. And everybody here times 4. +12x, +20y, 40, 68. God, I should have thought about that before I did it. Yeah. Are you happy about that line, what I just did? I multiplied the first equation by -3 so I could get that guy. And I multiplied the next equation by 4 so I could get that guy. And now we're good to go, because at this point onwards, isn't it just a normal, simple addition method? Right, just like we did at the start of today. So I'm going to add them. And in this case, they cancel out. In this case, you end up with +14y. And in this case, oh, good. I'm glad I did it right. You get 14. You agree -54 plus 68 is +14, which means that y is equal to 1. And now I'm going to substitute y equals 1 into, oh, this one might be a bit harder for you to guess. Which equation do you think I'm going to pick? Doesn't need to be the one you picked, but it's one I'm going to pick. They all work, but which one do you think I'm going to pick? Because you know I'm lazy.
Bottom one.
Well, this one? Oh, I'm lazier than that. That would work, by the way. Nothing wrong in doing that. You get the right answer. I'm even lazier than using that one. Which one am I going to use? Because I'm really lazy.
Number 1 then.
Yeah. Why? Everybody's positive and the numbers are quite small, right? That's the only reason. So I'm going to put y equals 1 into here. So it's going to be 4 lots of x times 2 lots of y are 18. 4 lots of x add 2 is 18. Subtract 2 from both sides. And then divide both sides by 4. And we've solved the problem. And do you know, if I went to Desmos and I typed this in and I typed that in, wouldn't you get 2 lines and they'd cross at coordinates 4, 1, right? So it basically checked that I did it right. Now, I'm not doing this question because it would take too much time, but suppose I covered these up. Couldn't I get rid of the y's? Now, I would have to tweak it a little bit, but wouldn't I multiply this guy by 5 and this guy by 2? And then I'd decide which one I want to make negative. I'd probably make this negative. So it'd be -5 for the top one and +2 for the bottom. And if I did that, all the things here would look different, except the answers would be exactly the same when you're finished. So it's very versatile, this method, doesn't it? You can get the x's first and the y's first. You can get rid of the x's first. You can get rid of the y's first. You can make one of them negative or you can make the other one negative. See how versatile it is? It still works because the method is, you know, pretty robust. The whole trick is get the same number of x's, 1 plus and y, and 1 plus and 1 negative, or the same number of y's, 1 plus or 1 negative. If you can do that, doesn't it just become a simple addition method? Right? You add the equations and off you go. Do you feel ready to take one of these guys on yourself? You want to try one? Okay, so let me make that the next question then. We'll keep that ugly fraction one till Monday, right? The one I've kind of avoided. I think it's probably better to deal with that when we're fresh. So, well, here's a problem. There is no guarantee that the question I'm about to give you won't have a fraction in it, because I'm getting tired and I might accidentally make that happen. So I'm just warning you just in case it does happen. So let's do a 5x plus a 3y. And let's do a 4x plus a 4y. Oh, I'm going to be sneaky here. And I'm not even going to tell you what's sneaky about it. I'll let you figure it out. This question does have a solution, right? So it's not sneaky like there's no solution or there are infinite solutions. It's another sneaky that I've put in here. Okay, you have got 3 minutes. Go for it. Some of you need a head start. There's one of the many ways you could solve this. You may already have chosen a different route, and that's fine. But if you want a kind of a start, multiply the first one by -4 and the second equation by 3, and that'll get you started.
Is it okay if you did -3 instead of -4?
Perfectly fine. And you know, it's also okay if you did 4 and 5, where one was negative and the other was positive, because there's lots of different ways to do this, and the one you mentioned will work.
Okay, I just wanted to make sure, because now I'm trying to find y and I'm having trouble.
That might be because I warned you it's going to be sneaky. I did, didn't I? So you figure out what that y is, because I'm being sneaky.
I think I figured it out.
Ah, well done. Francis, there was nothing to that problem, was there?
Yeah.
That's a little joke between me and Francis right now. Right? There was nothing in that joke, was there, Francis?
Yep.
Okay. Last few seconds. Now, the one that I've set up here is only one of the possible ways that this could work. Someone said, could you switch places? Make that +4 and make that -3. Yes, you could. Couldn't you also multiply the top one by 4 and the bottom one by -5? or the top one by, I've lost track of the numbers here, -4 and the bottom one by +5, right? So there are 4 possible ways of doing this, all work, all get you the same solution. So that's not a problem. It does mean, however, that my working might not look like yours, but what will be correct is we'll both end up with the same solution if we did it properly, okay? So if you multiply everybody in equation 1 by -4, you get -20x, -12y, -40. If you multiply everybody here by 3, you get 12x plus 12y equals 24. Nothing that unusual happening. You can then add. If you add these together, you get -8x. These kill each other off. And I believe you get -16. At least I hope you do. Does that look good? And then you divide both sides by -8, and you get a really good answer. You get a really nice answer. You get 2. So far, so good. And now I'm going to substitute, and this is where the sneaky part comes in. I'm going to substitute x equals 2, and I'm going to put it into, I don't know, I'm going to put it into the first equation because I'm kind of lazy today, which is that equation, right, that one up there. And what's that going to get me? 5 lots of 2, add 3y equals 10. 10 add 3y equals 10. Take 10 away from both sides and you get 0. And that's maybe where you start going, oh dear. But it's not oh dear, Bailey, because don't you divide both sides by 3? And if you divide both by 3, Francis, there's nothing to it.
Yeah, you still get 0.
You get 0. And so the solution is x is 2, y is 0. Did you get that, Bailey?
Yeah, I
You
did.
Right. It's just sometimes, can't you talk yourself out of the solution because you've done other situations and you think, oh, I wonder if that's a parallel line, or I wonder if that's, you know, some wonky thing like we did earlier. No, it's just 0. Right? It's just sometimes you, what's the word? I think sometimes you overthink things, don't we? That we get so,
I just kept overthinking all of them. I was like, nope, that doesn't work.
don't talk yourself out of it, right? I'm a big favor in go for obvious until it doesn't work, right? If the answer is just obviously 0, try it out. And if you weren't that sure, couldn't you plug these into Desmos and just find out? Right? And you would see that at 2, 0, which would be what in the x-axis, the 2 lines would meet. So I'm not saying this is what it looks like, but can you imagine 2, 0s here? You'd probably get something that looks like that. Right? And you'd say, 2, 0, 2, 0, I'm cool. So if you feel a little bit hesitant, yeah, I like Desmos, the graphing software. Isn't it kind of helpful? But don't use it in the wrong way. Don't just plug that in, get that answer and write that down. Because in homework, we won't know that you've done it that way. Right? Yeah. As far as WebAssign is concerned, it doesn't know how you got the answer. And I probably won't know unless you tell me. But I will know when I give you the homework, when I give you the test question and I say, solve this equation using the substitution method. And you can't just tell me the answer because I'll give you 0 points because I don't want to know the answer. I already know the answer. I want to know how you got it. In other words, I want to see all this stuff. And if you don't do this, you won't be able to show me it, right? You won't have the method in your head because you never bothered to learn it. So I'm being quite pernickety, but it's important. Math is, you should be able to prove things in math, and this is how we prove things, right? This is us doing it through algebra. Desmos is good for checking answers, for verifying answers, for visualizing what the heck's going on. It's great for those things, but it shouldn't replace the math, right? And this is a perfect time to finish. So say hi.